Great. So so this is really about a little package that makes some things easier, I think. It's nothing of great consequence, but I like it. So so I mean, I suppose the context, retries come up in quite a lot of cases, and it's kind of, like, okay, you basically always want to do it if you're making a network request. Sometimes you want to do it in tests, where you're maybe polling because you don't want to delve into the detail. You don't want to be too dirty in your tests and rely on the internals, so you sort of wait until something's true. Or in database context, you might wait retry stuff until you don't get a conflict. That kind of thing. It comes up all over the place, and it's kind of trivial, but not entirely trivial. The usual approach that you kind of start off with is you just you put it in a loop, and you put a sleep at the end of the loop, and you do it for like 10 times or something. But the characteristics of that aren't great when you have like loads of clients all doing the same thing, or loads of things in the database all trying to do that at the same time, because you tend to get synchronization between the different clients. So that clock, pendulums that all start off at different times, they tend to get synchronized, and then you get this all these things battering the server all at the same time, otherwise known as the thundering herd, which isn't great, really. A classic way to sort of get around that, well, the other thing is you make far too many requests. So often the length of time you're going to have to wait is going to be fairly short, but sometimes it may be quite a long time, and you don't want to keep polling really, really fast all the time. So you have this, you do an exponential backoff, but then that's still vulnerable to your thundering herd problem, because often something goes down and then everyone's backing off at the same time, and then they get unsynchronized. So they'll all be backing off like 1 millisecond, 2 milliseconds, 4 seconds, and then you get to 1 second, 2 seconds, and they're still all in synchrony. So you probably want to have some jitter, some randomness involved. But there are a bunch of ways that can work too. And it's not immediately clear which ones are better or worse. And to be fair, I just relied on this article, where somebody else had done the investigation. It's a good article. You can click the link. That's a working link. You can look at the slides afterwards. But basically, they investigate a bunch of different algorithms, including and you can see in that graph that the context of that they're doing it in is databases, and everyone's trying to do something at the same time, and if there's a conflict, then you get an error and you retry. And so the context here is that we've got this work. That's the amount of work you actually end up doing, a number of calls you end up making until you don't get a conflict. And there's various different algorithms. So you can see that if you're just doing like just retrying without any kind of backoff at all, then you end up doing loads of work. That's the pink line at the top, purple line at the top. And then just standard exponential backoff. That's not actually that much better because they're all correlated. Then this one's interesting, because this is probably the algorithm that I would have used naively. The decorrelated thing is basically will back off, but with some percentage of jitter. So rather than so when we've got so with exponential backoff, you'll say start with 100 milliseconds, next one's 200 milliseconds, and the decorrelated thing here is that when you add your next try, then you vary that by some percentage. at like 10% or 20%. And I found there's quite a lot of algorithms out there in the wild, places which are doing this kind of thing, and that's what they do. And it's clear that from this graph that actually that does more work. Now, I can't quite remember the what equal jitter is, but it's pretty similar to full jitter, which is just a tiny bit better, maybe. And what full jitter is like exponential backoff, except every time you multiply the delay and then you sleep for some period but from 0 to that delay, randomly distributed. And that turns out seems to be quite a decent algorithm. So I think, my opinion is that probably, but that's a reasonable decision to make if you're going to choose something. And here we will choose something. Maybe there are situations where the decorrelated thing is worthwhile doing, and maybe we could go with that. So, like, here's an example of something of like a loop in the wild. I looked in our code base at work, and I grepped through all the dependencies, just the dependencies of that, not worldwide, but they're all reasonable dependencies. I grepped for exponential backoff, and I found lots of places that we're doing this. And here's sort of classic example. This one, for example, is not doing any. By the way, if anyone has any questions at all, please feel free to speak up. It's not doing any jitter. It has, often it's up to some kind of maximum delay. And you can see it's got some number of maximum attempts, some maximum total maximum delay, but it's quite bulky. This kind of thing. It's actually it's not great. And yeah, as I say, there's no jitter. It would be a little bit annoying to put that in. And there are this is actually quite a well used library. I've seen this used in various places, this Go auto rest library. But you can see, there's quite a lot of stuff going on there. And here's another place, which is kind of factored it out a little bit within itself. This is an etcd. It looks like it's in the etcd server. Again, no jitter. It's just, there's just quite a lot of, there's loads of play. In fact, if you look, there's just a random selection of places that were in our dependencies that had this thing, and that were using, some had their own implementation of backoff. So these are sort of out of the box packages that provide some kind of retry functionality. And I didn't really like any of them. And a lot of them have, a lot of their own dependencies, or they're part of some larger thing which has lots of dependencies. They don't, for me, none of them really hit the spot. So there are a couple of different approaches that seem to be common. There are loads. I found lots of people that this is the approach that most people will think of when they want to write some functionality which provides retry out of the box. You basically do a callback type approach. So here's, this is one particular example in the Kubernetes client. And like in this case, you've got a function that returns an error, and this function, this on error program, retry.onError, will call this function until it doesn't return an error, or until the error it does return, it passes that through retryable, and if that returns false, then it goes off. And you've got this backoff structure which actually tells you how to back off. Now, I quite like having that as a separate thing, but this kind of idiom is actually kind of awkward to use, because you end up doing things like this. You end up, if you're doing a sort of one-off retry, you end up, we're trying to get a value, and okay, we're going to retry something in order to get it. And you end up doing this, and then you're like, oh, but we're in a callback. Oh, damn it, we can't return from inside that function because we're inside a function. We're not inside the function. We want to return the outer function. So then you end up having to declare variables, assign to them. It's a little bit error prone. It feels awkward. It's just not. It just doesn't feel great. It's not. Doesn't flow. I'm not keen on it. In general, in Go, I try to avoid callback based APIs for that kind of reason, because the other thing that you're not in control anymore. You're giving up control, which means that the loop is somewhere else, which means it can't be your own loop, right? So you can't add other conditions to it. It's just you can't return out of it, you can't break out of it. It's just less flexible in general. And another approach that that I've seen quite often is having something which just gives you just tells you how long to wait. So it's basically just got that time calculation in it, and here's an example, and it'll have some various algorithms which tell you give it, this is how far I'm through the loop. I'm in attempt 0, 1, 2, 3, etc. And it says this is how long you should wait, which is fine. It gives you something, but it's for me it's still not great, because you still end up with a bunch of boilerplate. You actually, in this case, it didn't actually. This algorithm just provided you with a time duration. It didn't say, there's no way for it to say stop now. This is your retry attempts are finished. So you end up having to do that. You could have an algorithm which did more than that, but it's just again, it's a little bit just a little bit more. It doesn't do quite as much for us in the common case, but at least if you're doing something like this, you can actually return from within your loop, which is quite nice. So I quite want something that's just basically a normal loop, and the way that we do that in Go often is by having something that looks like a kind of, and we don't have iterators at first class objects in Go, that there's no language concept of iterator, but we have this convention where you start something off and then you call next in the condition. So this is kind of starting point, the motivation behind this API. Let's have something a bit like that. So where strategy tells you, this is how you're going to back off, and next reports whether you need to continue, but also sleeps for the next iteration. And actually, interestingly, that was the API of this retry package until I came to write this talk, and then I actually changed it. So this is the package I'm talking about. This Roger Peppe /retry package, and actually I did have another retry package that I wrote years ago, which is kind of similar, but I prefer this iteration. And also that other one was under an LGPL license, and that meant that I couldn't use it in my current job. So I was like, okay, this is a good excuse to rewrite this whole thing. So yeah, this version that I'm talking about is a little bit less general, but it's definitely simpler, and it's loads more efficient as well, if efficiency matters, which it might do in some cases. So the basic outline, this is how you'd use it. So you say you start strategy, and it returns it calls the type is called iter. So I seems to be a reasonable name for a loop variable. Why not? It's fairly standard, and the way you structure it is like a do while loop, basically. So we've got this do thing. You do it at least once, and if you and then next wait until the next iteration and returns false if you're supposed to stop. So that's and there's a parameter to next, which I'll go into in a moment. But it's that simple. That's the basic idea. And the reason that I went with this kind of do while kind of approach is that it makes it bother. Well, no, actually, this demonstrates it quite nicely. It makes it possible when you're returning to actually use some of the results that you've previously encountered in the loop. So, for example, here we returned an error which was included, like how many times we went through the loop. This is a little feature it provides too, and it included the error that we just returned. So one issue with this approach is that if you've got a loop like this, I.next, then you have the error, and then you find out in the condition that you're not going to have another thing, and then another iteration, and then you're like, oh, damn it, the loop's finished. I can't get back to this error that we just happened. And I had a little method in the API that would tell you whether you were going to get more iterations, but actually that was kind of a bit awkward, and this seems nicer to me. And also it makes it clear to the compiler that, oh well, it knows that this is well, it's not an infinite loop, but it knows it can't get out of this, which means that I don't have to put a panic unreachable or something at the bottom if it's never going to get out. And the strategies, like we've got it basically, you could it's a struct, and it can I'll talk about it in a little bit, but it can express linear and exponential backoffs. It's got a duration. It can jitter, and it can express some limits on the overall duration and number of iterations. The other thing is that quite often you don't want to just wait for the retries. Maybe there's something else which is going to tell you, usually a context or context, but not always, when things want to finish. And in this case, you can pass a stop channel to like a channel of struct, empty struct to next, which is okay for ctx.done. But I decided against passing a context in itself because that's a little bit of a higher level API, and this is actually a bit more versatile because you can pass your own channels in there, that kind of thing, and passing context.done is trivial too. And the other thing is that sometimes actually you do want a bit more flexibility, because this next this actually sleeps, but sometimes maybe maybe you want to, for testing purposes, you want to fake out the clock, fake out time, or maybe you want to you've got two or more things that you want to be retrying at the same time. Well, this makes that possible. So next time just returns you, this is when you need to sleep until, and then you can make use of that information. It doesn't actually sleep yourself. It means that you can, if you've got a select statement which is waiting on more than just the stop channel, or the done channel, then you can do that as well. And also there's a couple more methods which just tell you try time basically returns exactly what next time just returned, but it doesn't keep updating it itself, and start time tells you when the loop started, which could be useful for some kinds of calculation, I think. So here was a little example that I came up with, which is like, okay, so we've got something which is managing any number of backoffs, of exponential backoffs. This is we've got a little we've got an actual binary heap, which we're managing, and all of them. So we're just calling next time on the one with the earliest deadline in the heap, and the criterion for heap is basically look at the time and have the earliest time is the bottom of the heap, and so this works. Let's see. Whoops! Oh no, it's not working. Oh well. I thought that was working. Damn it. I'll have to find that in the. In fact, I'll just. I've got too much stuff open here. This is probably too small for people to see, but. Here we have it, running away. Exponentially backing off to a limit of 10 seconds. So this is the actual code for that, and it's pretty small, pretty easy to do. Just an example of the sort of generality you can do. The other thing that I thought was nice to add, that I've often thought might be kind of fun to have, is that you can actually serialize the strategy, the backoff strategy, which means that you can treat what strategy you use in wherever you care about. So say it's something where it might depend on your network characteristics or something like that. You can actually say, okay, we'll just take it from a string and decide at configuration time what kinds of backup strategy you want, and it's just this simple textual format. I mean, you could use JSON as well if you like, but it's maybe nice in a way. You could have an environment variable holding this stuff. You're holding. In fact, I haven't. I missed this out actually. I haven't actually pointed to what strategy looks like, but you've got a delay, a maximum delay, and this. So here we've got. We'll start off with 1 millisecond. We'll exponentially back off till 2 seconds with a factor of 1.5, and we'll try as long as for as much as a minute. So, like as a sort of basic summary, the API is pretty small. I'll show you in a moment the whole API, but it's pretty flexible as well. It's pretty efficient. If you're needing to use it in a tight spot, then it doesn't necessarily do any allocations, and the overhead for creating and using it is about, I don't know, on my machine less than 40 nanoseconds. So pretty small. It's very low level, so I'm hoping to be able to use it like the couple of microcontroller projects that I use. I reckon it would probably be a decent fit for MicroGo. No, it's called TinyGo. TinyGo, that's the one. So I think it probably work well in that kind of case. And yeah, I think it's maybe a reasonable sweet spot in terms of APIs. So I'll show you the so that's the API. Oh yeah, I'll show you strategy. So so this is the kind of heart of it, I suppose, of how you'd specify it. It's just a struct rather than a set of options, which means you can serialize it. The essence is delay, This is from delay to maximum delay. They all have useful zero values. So if it's all zero, then yeah. So if max delay is zero, it'll be treated the same as delay. Your floating point factor, which defaults to 2. Whether it's regular, so by default it's exponential. Regular means there's no jitter. What your maximum number of iterations and how long the overall loop will take. And yeah, so that's the API, and I'm fairly happy with it. And that was maybe too short to talk, but that's basically all I've got. Any questions?
I wrote a brief question in the chat, which is, as you were walking over the API now, I was wondering, should we expose a set method instead of a parse func, kind of like the flag value interface?
Good question. I mean, I went with something like time.duration, which I thought, if it's okay for this time.duration, it's okay for this. I'm not sure about implementing flag directly. That seems a bit presumptuous somehow.
Yeah, maybe not flags. I guess I was thinking of encoding, decoding in general. So maybe encoding text on marshaller, because for marshalling, you already do have string.
Yeah, I mean, I thought that too. But then again, it might actually be nice to be able to, if you do that, then this doesn't, then you can't marshal this as JSON in this structure, in this struct way, which, maybe that's actually nicer for some people. But yeah, I've definitely thought about that. I'm not sure about it though.
No, yeah, that's a very good point. Actually, I would want this to marshal as a JSON object, I think.
I think probably. Mind you, if you wanted to do that, then you'd probably put some emit empties. Don't know. Yeah, I thought basically I'd keep it. I'd provide parsing and string and sort of leave it at that, because seems sort of sufficient at any rate.
I was also wondering if you have an estimate of what's the smallest durations that this could be reasonable to use with. Like, for example, if I use it in the scale of microseconds or even nanoseconds, is the overhead gonna be too much?
I mean, in all honesty, that's pushing the overhead of of time, time.sleep.
Yeah.
So if you're pushing the overhead of time.sleep, I'd say the overhead, it's good enough for anything that time.sleep is good enough for. And if you're using a stop channel, then it's slightly less efficient again, because it uses time.timer underneath, and it has to do a select, so that will impose its own overhead too. I think it's basically about as efficient as it can be, within the constraints of Go.
So I guess you would expect most people to use milliseconds at the very least.
Yeah, I mean, I think you'd probably be fine with depending on, the clock resolution is not great on lots of, if you're using, I don't know, Microsoft Windows, I believe that the clock resolution is pretty terrible. So yeah, milliseconds is probably all you get there anyway, right?
But also, like, it depends on the payload or on the work itself. So like typically you put the retry on the network calls, and network calls, like, they are milliseconds at least.
Yeah. Yeah, I mean, absolutely. In the network call, in the network case, then you're probably going to start at 50 milliseconds or something, and or a few milliseconds and go up to seconds. But I imagine this could be useful in places where you're dealing with concurrency on a local machine, for example, when you're talking to like, yeah, there's sort of when you've got contention for a in-memory database or something. So, you know, in that case, the timings might be much smaller. And I wanted this to be good for that kind of use case as well as, so the original API that had the gopkg./retry.v1, that would like do an allocation. It didn't really mind so much because it was written with very much the network use case in mind. So, okay, well, we don't mind about an allocation here and there. But I wanted something which would be fit for most purposes, basically.
So it seems that I like how many things you can do with so little code, but just as an aside, can you go back to slide number 8? It was the one about the callbacks.
Yeah, hold on. Slide number 8, remembered. Yes, yeah.
Or 9, I think, maybe. Yeah, 9.
Yeah.
So yeah, the biggest problem here is that you cannot return from the callback. Now, I'm not suggesting this is a good idea or anything, but I think this problem is solvable with generics nowadays, because you can make the retry function return this whatever you want to return. So you can make essentially.
Yep.
In getful you can just do return retry that thing.
You could absolutely do that. So you could do something. Your on error function could be something like retry dot I can't remember what it's called. That kind of thing, right?
Yeah.
I mean, but you're still giving up control. I mean, you know.
I know. I mean,
it's still not ideal. You know, maybe you don't have a return value, or maybe you want to just break out of a loop, or maybe you want to break out of 2 loops, or maybe, yeah, as I said, maybe you've got.
It's far too low level. It doesn't expose like the primary pattern. It's missing. So that's
It just never, yeah, as I say, callbacky kind of APIs. You know, the problem with a callback is that you've given up the only control flow you have. So if you want 2 of them, then you're out of luck, right?
Exactly.
And that's why I gave this, you know, the sort of perhaps a bit ridiculous example of the, you know, the heap. You can have any number of them, right? And that's just fine. It worked quite neatly, I thought, the heap-based thing.
I've got another thought about the API, but maybe this is getting a bit too specific into just the API. But I've seen people make the mistake of giving, for example, what was the delay? Imagine you say delay :5, and you forget to multiply by time millisecond or time second.
Oh, yeah.
It's a constant. It becomes 5 nanoseconds.
Oh, yeah.
And since we said nanoseconds will basically never make sense, maybe you should error if any of the durations are non-zero but smaller than, I don't know, 1 microsecond.
So one decision that I took was not to error on anything. So there are no errors here at all, and I quite like that. There's, you know, you basically can't, you know, there's nothing you can get wrong with I mean, you can probably get something wrong, but everything has some sort of meaningful thing, which, you know, because otherwise the API becomes much more awkward to use, because you're like, okay, well, I want to start with this strategy. Okay, well, I have to check the error first, but I'm not in a place where, you know, I might not be in a place where I can easily return an error.
Yeah, and you don't want to panic either, because if the user is supplying the duration, then that could be like a DOS of some sort.
Yeah, I just wanted some sensible behavior for every for every possible for all the values. And yeah, I mean, arguably that you could provide some validate kind of method, but then again, anyone could do that, right? Anyone could provide their own validation, and the level of validation is appropriate to, like if you're, for example, if you're doing exponential backoff, then starting with a nanosecond is probably fine, because in about 8 or so tries, you'll be, or so probably 12 or 30 tries anyway, you'll be back in reasonable territory, right? So yeah, I mean, I think it's all trade-offs, right? And that's why I saying I hope this is a sweet spot, because it is definitely trade-offs, right? And there's nothing that's absolutely perfect, but maybe this is closer to good than others.
Yeah, personally, I really like the configuration string as opposed to other kind of options. Really, like it's easy to pass around programs and things like that, including scripts and human input. And
I did have a more concise notation for it, which I quite liked. But Daniel rightly pointed out that it was a bit hard to read. But basically, the idea was that you could say from you could up to 1 second. Actually, it was 1 second. Semicolon, 10 or something like that. That would be valid. That would be like, for 1 nanosecond in increment exponentially by 1.5 to 1 second maximum, and then for a total of 10 iterations, which is kind of cute. But I actually think
it's very cute. But I think the real problem with this is it's more difficult to generate from a program, for example. Whereas the other one, if you just have like variables, you can just say foo equals bar, and it's just
and it's really there's a nice one-to-one mapping between the between the mapping between the configuration and those. So yeah, I think it's better as it is, but I quite like I had a little quite soft spot for that concise notation.
I guess you could always make parse accept both, but at least for me, I don't think I would ever remember exactly what characters to use for the short version.
Yeah. I mean, obviously for me, it was kind of, it seemed fairly intuitive, but that's just because I had invented it, right? So,
I would agree. Like so far, like the brutality of the computer software is that you write it once, but you read it like 100 times or 1,000 times, and not only you read it, the other people will read it. And in the computer systems, a human is the slowest component in here. So it's better to add more symbols to the string for the human to understand and let computers do their job.
I agree, and that's why when Daniel said that, I was like, yeah, you're right. I'll change the parsers.
Yeah, so like that's exactly it's human readable, and human here is slowest, and the human here who does the errors.
Yeah,
hard to get.
Cool. Do you think you'll get to version 1 before you start using it?
I think it's pretty close to version 1 now. I mean, unless people point out, I want to make it version 1 very soon, basically.
The only reason I can think of where you might want to wait is if you think you might use generics in like a year's time, but I don't think you will. So
I can't see any reason why this package would ever need to use generics. It's a low level thing.
It's like pretty clean wrapper.
I mean, it's the kind of I could actually see it in the standard library. Not that it'd ever be accepted, but I tried to make it with the standard libraries standards in mind, so to speak.